goodness. Okay, all right. I'm sorry.
That's all right. Before you get started, right? So from an agenda standpoint, right, we've got you up to do a quick review of your updates, and then Anthony Wren contacted me earlier today and said that he's not going to be able to make it.
Okay.
Feeling well, so that opens up some time on the agenda. If there's somebody else that has a particular item that they would like to add to the agenda, we should have some time to look at that.
All right.
Is there anybody else that has anything they want to add to the agenda right now? Okay, no problem. And then Phil is also on the agenda, so we'll talk in later. So.
Yeah, Steve, I'm sorry, I was on mute. This is Pedro with Huawei.
Hey, Pedro, sorry.
Yeah, it's all right. Hey, so yeah, we don't have something to add to the agenda, but we would like to. Last meeting we mentioned maybe putting together a proposal for our kind of a 12-volt architecture for the addendum.
Yeah.
So we'd like to maybe get on the agenda for the next meeting in December. Should I just send you an email about that?
No, I mean, we'll just add you on to our note for next week. So, or
okay.
You can just add yourself if you would like. Just put yourself on the agenda under the November heading. I'm sorry, the December heading.
Okay, I'll have to see if I can do that. Okay, I'll try to do that, and if I can't, I'll just send you an email directly.
Yeah, no problem. I can do it. I'm already on there. So
okay.
I'll add you on December.
All right, thank you.
Yeah, no problem. All right, Scott, why don't you go ahead and provide a quick review of the updates that you made.
Sure.
Scott, do you need to share your screen?
Yeah, actually, that would be very, very helpful
Okay.
to be able to scan through a few things.
You should see a little box pop up, and you can.
Yep.
Yep. Okay.
All right, and so the show my screen.
Yep.
All right.
Great.
And let's see. I'm not sure. Right now, are you getting my screen? Can you see it?
Yes.
All right. I'm gonna need to bring up a. Let's see. See if I can bring up another. How much? So the whole thing, whole window there.
Yes, and
So
you can select
bring
show
up
just
another-
the
okay.
application if
All
you
right.
want to.
All right. Fair enough. So let's see. That looks like that might be the little icon that's two cascaded boxes, possibly.
What are you trying to do?
I'll tell you what. I'll tell you what. I'll start displaying, and if I can get like feedback whether people can actually see what we're looking at or not, that'll probably be enough. And is everyone else seeing that go to control dashboard as well with a microphone and whatnot, or shall I?
No, that's hidden. That's hidden from everyone else, so you can keep it open.
Very good. Okay. All right. And okay, I'm going to go to the 0.4 spec. That spec itself was one where we actually removed some of the highlights I'd added to the 0.3 spec to show what had been changed. But I guess to summarize where we went with the feedback we got was there was a fair amount of feedback on being very careful about calling out the BMC on the payload as the only thermal master. So one of the first things that we did, I'm just going to skip forward to thermal design requirements here, page 9, and we'll do a quick little overview of that. All right. So I tried to break out the control loop schemes or list some control loop schemes that gave sort of a background of what we would expect to see in different flatbed implementations. The first one would be where the tractor board was a master, and I think that was I think that might have been Ed was talking about that a lot. You know, the idea being that you could use fan control chips or some sort of fan control loop that's located entirely on the tractor PCB, controlling the fans, and you wouldn't necessarily have to have any involvement by a payload BMC or any other intelligence there at all. And then another scheme would be, you know, you can just use the payload itself, entirely controlling the fans. The BMC and the payload will probably already come with fan control software, and that one would be sort of biased more towards an integrator that just wants to make sure, for example, their CPUs don't melt. And then the third scheme, which was more or less the original scheme that we came into the spec with, you know, from the Google side, was that we would have the BMC be a master, and it uses the thermal readings from the payload to control resources on tractor and interface between the data center's requirements and the payload's requirements. So it's those three schemes, tried to make them as sort of an explanation and make it clear that there's optional implementations. So that was the first thing. Let's see, there were a lot of slight nomenclature changes from tray to sled, trying to harmonize a little bit more with the way we talk about trays and sleds. And another big change was on the compliance side. That was, I think, Steve gave a lot of good feedback on, you know, it would be nice to have a fair amount of compliance and requirements for purchasing these tractor devices or flatbed PC boards. So I'm gonna scroll down and try and give sort of an idea as I scroll down. The general thought was that both the payload and the rest of the flatbed tray both need the same compliance requirements. And what I wanted to do was create an appendix, which is Appendix A, that talks about compliance requirements, but have specific callouts in both the sled part of the spec and the payload requirements part of the spec that talk about what the test conditions would be to meet these requirements listed in Appendix A. So I think that the key thing here, for just to look at the paragraph in section 14, which should be up right now, we're talking about emissions, immunity, EMC, that sort of thing. It's very difficult to get useful results, I think, testing the payload, you know, standalone on a benchtop, which was one original idea. So really the meat of testing has to be done with any payloads inside a flatbed sled. That sled may include or may be required to have specific shielding or extra filtering by the particular end customer, but we're going to set out that testing has to be done with the payload in the sled to be useful, and you can test a sled without a payload for compliance to sell just the sled. And let the end user decide what payload to put in if they're perhaps not sensitive to EMI or EMC. But perhaps for a colos type application or something like that, there might be a much higher degree of sensitivity. And so an integrator may be able to provide a integrated flatbed sled plus payload with shielding that meets various country requirements. So I actually have the same basic approach for sled reliability and quality. In this case, there weren't any additional clarifications, and I'm just going to scroll really quickly down to that compliance section, the appendix, and this appendix for the mostly safety and compliance here, compliance being mostly EMC. There's sort of some very familiar specifications listed that are for the most part taken from some of our Google requirements, but they're very similar to other recently released OCP specs. And And certainly welcome for any inputs if there's anything that doesn't fit or overly restrictive or anything that occurs to anyone. And we've got a few countries listed here. And then Appendix B was, I think I'm going to have to say, shamelessly cribbed from a lot of other OCP specs with minor changes. There were some additions and subtractions, but this will look very similar to people who have looked at some of the Microsoft and Facebook originated specs, and tried to some degree loosen a few of the requirements. One particular one is I didn't personally want to rule out through-hole inductors. But soften the spec to say only when a SMT alternative wasn't available, and changed a little bit of the derating numbers as well. So that is most of it, and we're trying to get a little more official and add some revision history. So now I should probably break right now and ask if there are questions or areas that were near and dear to anyone's heart that I might have not talked about. Okay.
So, Scott, I've got one question for you. So, have you thought about interoperability testing between sleds and the trays? So certainly you could get the whole thing together from one supplier, but what about testing?
Actually, that's a good point. Like that, I'm thinking of that as mostly a mechanical interop. I mean, I think we call out the electrical interface. Yeah. You know what I should do is I should read. I've been trying to reference Appendix C in the ORB spec to refer to the horizontal tray and sled. So I will take a look at that and see if there's anything more than mention of electrical compatibility. But when you say interop testing, is there to be specific, we referring to sort of mechanical, electrical?
Well,
meetings?
really, sure. So I think all of those. The mechanical stuff's pretty straightforward.
Yeah.
So some of the management stuff can get a little complicated. Sometimes.
Okay.
And I also like kind of extreme conditions for the power, right? When you've got say on startup, or you have your inrush current. If they're not necessarily well specified, you can get some kind of extreme conditions where it works in one sled but not in the other one.
Yeah. Okay. All right. So that actually, yeah, that's an interesting point. It sounds like as part of the open rack spec, there were requirements for fusing and hot swap listed, but not necessarily the detailed operational parameters, and that can vary from rack to rack to some degree. Yeah, I hadn't thought to actually narrow it down. Maybe if I put something in additional, it seems to me it might end up being pretty loose and open. Were you looking for like a particular? I guess with this spec, I wasn't targeting it so much to buying a particular single assembly as more as
Sure.
So
I think the interfaces between, say, the rack and the combined system that you've got are probably fairly well combined, or fairly well defined, rather. I'm thinking more like within the tray, right? If you have two different trays in the same rack from two different suppliers, can you mix and match anybody that's making a sled?
Yeah. That should be the case, and so it does bring up the point that we would need to have some wording about the end user has to specify, for example, the hot hot swap, startup peak currents, that sort of thing. There is some verbiage to that end in the OpenRack v2 specification. So I'll look at that and see if it looks good, and maybe a call out that call out sections of that specifically if it's specific enough, maybe.
Sure. I think I mean, as long as you feel that what's there is good enough, right? I don't know if you reference it again, but that would be an area where you need to be, I think, very sensitive, right, to make sure that if possible, right, one of the things the IC is going to be looking for is the test protocol to validate that trays and shells can meet your specification, right? You got a bunch of specifications, but what is the test protocol to reach compliance for the gear makers? Yeah. Which is essentially what you would like to see as well, right? Oh, we've already tested it. We meet this spec.
That's a good point. That maybe some of the EMI tests is specified a little bit, but I don't think the testing for the interop sorts of parameters is very well specified. So yeah, sounds good.
Exactly.
Okay. Yeah, it sounds like I can add that, and maybe it'll take the form of another appendix, but I'll see what I can put together that makes sense and sort of flows. Let's see. One other area that we hadn't finished is like I think I promised a couple times some better pictures, actual mechanical pictures, and still had a little trouble getting mechanical engineering time. So we may end up with some very crude pictures that just give a couple of examples. Something not quite as nice as a really good 3D view with real parts, but we'll see.
Okay, no problem. That's not as critical. It looks nice, but
okay.
I think that was all I had. So I don't know if anybody else has any additional items.
All right. I like that point about the testing, though. I mean, that is almost sort of a universal. If there's some sort of area where there could be interop or compliance, it's a good point to specify the test scenario.
Yeah, I mean, the IC will be looking specifically at that. And it's very common for people to write the specs, but not necessarily provide the test protocols that are necessary to validate that the product meets those requirements.
All right, great, thanks.
So, all right. Thanks a lot, Scott. I appreciate it.
All right, thanks.
Okay. Definitely making some good improvements. And just so everybody knows, we're targeting the December IC meeting for the specification to go live. So that's we're getting close to the end. If there's any other additions or modifications that you feel need to be included.
Yeah, I think one interesting. I mean, it really did get quite wordy, lengthy. So if there are suggestions as far as flow or organization, one area that I've kind of struggled with is how do you quickly and easily keep emphasizing that there are requirements for the payload, and then there's requirements for the sled plus all the shims, and those are generally two separate things, but they are tested and required to perform as an ensemble. So anyway, I'll keep taking suggestions for that for sure. Thanks.
Okay, cool. Thanks, Scott. So the next thing up is Phil was supposed to be giving us an update kind of on where he's at related to the CRPS adapters that he was interested in potentially building specifications around, but I don't believe he's on the call, nor Anthony. So looks like we'll get out of here early this time. One thing I would bring up to the group, So well, let me back up. We can discuss the CRPS adapters if there's other members that are present that are interested in talking about that without kind of understanding where Phil is at. I'm assuming we wanted to talk or wait for Phil first. Is there anybody that wanted to talk about that topic anyway?
Yeah, I certainly, this is Scott, I certainly have interest in that as well, because, it's just part of the whole spectrum of, what could be offered to do the same thing as the flatbed, shim things in. I don't have any new thoughts. So,
okay.
Yeah.
Yeah, I think I'm in the same boat with you. So I think there's definitely some interest. I'm just not sure where Phil is at, or if he already kind of started on the path of setting up a specification or what. So unless there's somebody else with some new, exciting, fresh thoughts on that, we can see if we can't get Phil to.
There was one thing, I think back at the workshop, there was a request for maybe a little more examples of, I guess you'd say, voltage profiles over time on the bus bar itself. And for things like that adapter, it might be helpful if, I don't know, I don't think we've made too much progress of drawing, like sample, I guess you call them waveforms, as you go to UPS and as you come back off of UPS and things like that, what the voltage ramp rates are and that sort of thing. But those could definitely be helpful to guide those designs.
Yeah, that's. I don't think I was. I don't recall that conversation. That may have been something you guys were talking about.
Okay.
But yeah, I could definitely see that as being interesting.
Yeah.
I mean, we have some specifications around it, but having some waveforms that everybody can kind of agree and use that as a test protocol for validating both power shelves outputs and as well as inputs into the whatever IT gear would definitely be useful.
Okay.
Does anybody have an idea of kind of taking the next step on that?
Yeah. Do we have a working spec already that someone has? So I don't have one yet.
Sure. Well, the only specification we've got would be the generic OCP.
Yeah. Yeah. Okay.
Specification that specifies, the maximum ramps and that kind of stuff. But there's not necessarily a waveforms associated with those that we could use as a reference.
Okay.
So,
maybe I should start reading that and trying to find those maximum ramp specs and I'll tell you what, I'll try and start drawing some hand drawings or sketches maybe, and we can send them out in the mailing list. Maybe take comments for omissions.
Yeah. Yeah, I think that might be a really good place to start.
Okay.
And kind of change of topic, but Scott, I was going to. Do you have like fusing? I think I recall that from previously, but do you have a sort of fuse definition somewhere between the bus bar and the IT gear?
Only in that it's calling out. It does mention a fuse is required. That's up to the end user. I have particular specs in mind, but yes, fuse and hot swap are definitely required.
Okay, I seem to recall that. I'm just going to check it again today. But,
okay.
Forgot to do that. Okay. Okay, so I think that's a good proposal for kind of stepping forward on the waveforms. Maybe we can get some of the power guys to chime in.
Yeah, that sounds good.
Okay, I can maybe chime in. This is Ed.
Ed.
From GE. I think the conversation that was being referenced as far as waveforms was about the transition to and from battery. I think we had that at the last meeting in Dallas. And the idea was that we wanted to wait for the power to come back up from a battery discharge before we turned on the battery charging elements inside a battery tray.
Okay.
And that's
yeah, that makes sense.
so there was a kind of a sequencing delay. Because the idea there is that if you do constant power all the way down to 42 volts, all your interconnects have to carry a lot more current, and everything, you spend more money on the product. And so if you just wait to turn on your battery charger until the voltage pops up to 48 or 52, 54, some voltage around 50, then all the current carrying load on recharge is much lower, and the cost should be commensurately lower. And I think that it's worthwhile you're looking for data on that. I think that how hard is that for you to get?
You mean
is that
me?
Easy or hard?
I
48 volt guys. 48 volt. Yeah. So.
Yes, that would be like sheet.
Scott, I guess.
Yeah. I guess when you mention data, do you mean like actual currents and charge profiles and a charge current as a fraction of standard operating current, or I guess. No, go ahead.
I think what we were talking about is adjusting the spec on the battery charging system that's in the battery shelf to not try to charge when power is restored until the voltage reaches the threshold of 50 volts or something like that.
Yeah, I could definitely see drawing a some sets of waveforms that show various points at which decisions are made. For example, you could have a system that attempts to recharge to limited current, or you could have a system that attempts to hold off charge until a given recovered voltage is achieved.
Yeah, voltage threshold.
Yeah.
How about if I take an action item to look at the battery shelf spec of the battery? I'll look through that and see if there's a place where we could maybe add the turn on voltage threshold for recharge to that.
But for that problem in particular, yeah. Okay. Sounds good.
Yeah, I think that's. Yeah, I was trying to remember what discussion you were talking about, and that was the one that we had in Dallas. So that might be there. So I'll take that action item.
Okay. Yeah. In fact, now that you mention it, it wasn't clear whether the problem was just the high currents and sizing connector contacts for extended operation at 40, or 30 seconds operation at 40, or what. So that some of that other detail could come out of some waveform drawings as well.
Okay. Yep. So I'll take a look at I'll put up a straw man that's pretty valid, and I can put that up whenever you. Is December, the second week in December, is the next time?
Yes, it is.
Okay. I ought to be able to have it by then. If not, the next time maybe we can talk. I'll tell you how it goes.
But what would the straw man? Oh, do you have a feeling for what the straw man might include? So I don't try and duplicate anything.
I can send to the group some sort of straw man so that I can send something out.
Awesome. All right.
Okay.
Yeah, we definitely use the mailing list, right, to kind of collaborate on those sheets. So.
Okay, great.
Cool.
We're not reproducing the same effort. Okay, Ed. So I will. I'll add you on for next week as well, or next month.
Okay. Thank you.
Agenda, and we can take a look at what, or we can have a discussion on what you find out.
Sounds good.
Steve, we had a question from Rafael Garcia about presenting something today. So Rafael, can you chime in? Maybe. Can you hear me?
Can you hear me, guys?
Yes.
My question was just because we have plenty of time, just to give Pedro from Huawei the opportunity to present something about his proposal.
I'm sorry, Raphael, I didn't understand that.
He asked if Pedro could present something for his proposal. I think that's what he said.
Oh, for this week? Or I did add him to the agenda for December. So
Oh, right.
Pedro's on there for December. All right, no problem.
Okay, no problem. Thank you.
Yeah, no problem. Yeah, you bet. Yeah, see if you can see the screen that Kelly's sharing, right? You can see that he's been added to the December agenda. There you go. Thank you.
Mm-hmm.
Okay. Anything else for today, guys? All right. Cool. So it's a good discussion. So let's feel free to use the mailing list to collaborate on these topics. And the next meeting is December 13th. So it looks like we've already got quite a bit on the agenda. I can adjust some of that around. One thing that we are working on is an update, a modification to the open, what was originally called the Open Rack Projects Charter. So now we're Rack and Power, and the charter that we've got out there is very dated. So I've gone through and updated that. So what I'll do is I will send that out to the group probably this week for you guys to review and comment on. It's essentially what what the goal of the project is. So if you got any feedback you'd like to provide to that, feel free to send that back to the mailing list so I can take a look at it. And the goal for that is to submit that also in December to the incubation committee, so that we can get that charter updated. So that's everything I've got today. Thanks, guys, and I will talk to you guys again in December. Thank you. Bye-bye.
Thanks.
Thanks.
Bye. Bye.